Good morning. My name is Greg Davis and I'm with CBS ArcSafe, and we're having a webinar today on the CBS ArcSafe RRS-1 Universal Remote Racking System for Rotary style switchgear. The RRS-1 has been one of our mainstay products for well over 12 years. One of the things I'd like to first cover, because we have had a couple customers call in recently and say they were having a problem with the RRS-1, and just listening to what they were talking to us about, we had to ask them to check the batteries, and that got the units back up in service because the AGM batteries that were inside had gone past their time of useful consciousness, so to speak. It's very simple to check these batteries. I have two screwdrivers here for this whole purpose. You simply open it up with a nice flat-bellied screwdriver, and if you have to change them, about a 12-inch long Phillips head screwdriver works. Whenever you're checking the batteries in the RRS-1, you need to make sure the unit is unplugged. It does require both of the unit's batteries to be in good order for the unit to operate and function properly. These are 12-volt, 8-amp-hour batteries. We use Duracell as our preferred brand. And all I want to do is I want to make sure that I have 12 volts DC minimum on each battery. Now, a 12-volt battery should hold, if it's fully charged and in good condition, 13.6, maybe 13.7 volts. So for this first battery here, I've got 12.7. And for my second battery, I've also got 12.7. So these batteries are in good condition. If I have a set of good batteries in the unit, I should be able to rack 50 breakers in and out just on battery power for the type going in and out horizontally. If I'm using the unit for vertical raising type breakers like a G Magnablast, instead of it being 50 operations, I would probably get about 10 just on the batteries with then needing to recharge them. We're going to rack today, starting from right to left. We're going to start out with an Eaton VCP-W breaker. Some things I'm going to show you real quickly in the cubicle before I hook up the RRS-1. One problem a lot of customers have is when they do this and they're trying to get this tool on, they're like always fighting with the interlock here because it's spring loaded to come out. Well, Eaton put in a lockout tagout function. So whether you're racking it with the door open or the door closed, if you'll open the door and put the lockout tagout in position, it will easily hold the racking mechanism exposed, so you're not fighting the spring while you're trying to hook up the RRS-1 to rack the breaker out. So now I can just put the tool on here and I can bring the RRS-1 up and then proceed to rack the breaker in and out. Now, one of the other things you need to know is this. The RRS-1 spins at a speed comparable to a man. And that's important because if you try and rack a breaker faster than what a man does, you can actually tear up the breaker and the racking mechanism. So we've worked to make sure that our speeds are close to what we can do as a human being. And I was a human guinea pig, along with a couple of other people, where we would literally get down and rack the breakers on our hands and knees with somebody timing us, and we would compare our speed to the RRS-1. And we played with different motor speeds to get us in the right speed range for this. There we go. Okay, so we've got the RRS-1 hooked up to the VCP-W. I simply now push it forward, and it's a stationary breaker. So I've put down my foot locks right here, so the unit's going to stay in position. Now, VCP-W breakers will normally take about the same amount of force that something like a G Powl-Vac does, and that will be probably in the 10 to 15 foot-pound range for going in and going out for most of the amp frame sizes, including a 3000 amp. We have seen breakers where those manufactured to the Eaton spec, we have seen entire substations where it takes like 27 foot-pounds to do every single breaker in a lineup, which is highly unusual, okay? The majority of times, these should take less than about 15 foot-pounds to rack in and rack out, whether you're looking at a 1200 amp, 2000 amp, or a 3000 amp breaker. So we will work with you as a customer to answer questions and help you look at the condition of your switchgear as you get into the remote racking process, because now you're not dependent upon somebody's arm anymore to go, I think this one was harder than the rest. You can have a numerical readout now with the radio remote and monitor the actual condition of the breaker in the cubicle to help you determine the health of your switchgear itself. So to start out with, the first thing I'm going to do for this breaker is I'm going to actually put the numbers down to 0 for install and remove. And so that way we're going to let the breaker tell us how much force it takes to bring the breaker out. So with the unit set to let me see, there we go. With the unit set to 0 and using the radio remote will have the remove and install buttons right here. If I hold the button down, it's going to run. If I release it, then it's going to stop. And so what we're going to do is we're going to use our peak current button right here to help us record what is the peak current when we rack this breaker out, so that we can figure out how to set the unit to minimize the amount of force we use when we rack the circuit breaker. So all I'm going to do now, I've got the unit hooked up. We're in the connected position, so now I'm just going to hold down remove. 5.7 is our peak, 6.6. So and once the breaker comes off the bus, that peak number actually goes down in terms of how much force is being used. It takes about a minute to rack a VCP-W breaker because it's around 59 to 60 turns on the screw for the system to rack the breaker. Okay, so now we can set our remove value at 8.6. Which is simply 2 above what it took to install or rather to remove the breaker. And now we're going to do the same thing. We're going to go back in now, and we're going to do the install operation. Okay. And we saw the number go up to like 8.2, so I'm going to set 10.2 in there for my install number now. And now the unit's set up to rack the VCP-W breaker in and out with just the push of the button. And people say, well, gee whiz, I've got 20 of these breakers in a lineup. We look at the fact that these breakers are made mechanically similar. So they should be using similar numbers all the time to rack. And when things aren't racking with those types of numbers, is when the switchgear is actually trying to tell you, the customer, that you may have a problem with your switchgear and you need to start scheduling maintenance to get things fixed so that you lose less outage time and you keep your stuff up and you keep yourself running and operating more. So now, if we touch the remove button, it will simply rack the breaker out by itself. Okay, now we're ready to rack the breaker back in. Okay. So that's how simple it is to set up and operate. The VR is right up here. We're going to move to a square D VR next. Yep. I'm going to rotate the unit just slightly so everybody can see it, but this is the power slide feature on the RS-1. So we've had some questions about that as far as how are you going to raise and lower the motor. This is one of the options. If you have a breaker lineup like just Westinghouse DHPs or Eaton VCP-Ws that are just in the bottom cubicle, you won't need it. But if you've got breakers that are in top and bottom, 3 or 4 high, you're going to want the power slide. Mm-hmm. The high lift will allow us, this is one of the other options. So let's say that I've got breakers that, you know, I've had to transport this unit around a plant. I've got pipes and everything that are up to here, so I have it collapsed down. Now I've got to go get like a GE AK breaker that's in a top cubicle. So now I can reach something that's up at like 83 inches off the ground for the racking mechanism. So that's the advantage of this, and then we can collapse it back down for moving it around the plant again. What I normally do when I'm adjusting the height, because you can't always see this from the back or necessarily from the side, is I'll work to get these to where they're just about at the same height, eyeball wise, and I normally go straight on to it. For this one, I'm just going to do it from the side and then I'll finish it. Okay, and so now I'll simply line the unit up, but I should be pretty close right now to what the actual height is for the racking mechanism. And I need to bring it up just to here. There we go. Now let me make sure I've got my motor brake off. I do. And now I can push it forward, lock it into position, put the motor brake back on, reset it. The same way we would learn the numbers for a VCP-W, we can do that again for a VR breaker made by Square D. There's not that much difference, but we'll just again show you how we do this. We'll take it down to 0. We'll let it record the peak for us. And so now we're just going to hold down our remove button because we're in the connected position. And the number is actually pretty close. It's 5.5, just took it off the bus, 5.6. On a square D, you're normally looking at about 24 to 25 turns or so for it to transit. So 5.6 was the remove value we saw, so we're going to set in 7.7, or 7.6 rather. Now we're going to do the install on this. 4.8 is our start. And it's just moving the breaker. It's opening the shutters right there. .4 and 6.4 was the install, so we'll set it up at 8.4 for install now. Here we go. And now if I just push the remove button, out it comes. Okay. So that's how simple it is to set or determine the numbers. You don't have to determine the numbers every time. The thing that we've seen happen over and over again is a family of switchgear should use similar numbers for racking. So when I first started doing this, this is a sample from back in 2009 on a 50-year-old lineup of switchgear in just on the north side of Shreveport, Louisiana. ITE HV gear. 15.4, 15.7, 15.4, 15.7, 15.7, 15.7, 15.7, and the last one was 25.8. And at that time, that's how we helped the power plant determine they had a problem with their switchgear, because we could show that it physically took more force. Now, I'm not a cubicle diagnostician, so I'm not a guy who can tell you exactly what's wrong. The RRS-1 is helping you look at and to determine that you do have a problem, and you get a qualified person to come in, because with older facilities you can have settling foundations, you can have worn racking mechanisms, bent racking mechanisms, you can have dirty finger clusters where people have mixed the various bases of grease, and so now if you've got like rosettes, they don't open, they behave like concrete. We've seen that. We've had to help people with our service companies like Circuit Breaker Sales and Repair in Houston to go out and clean up finger clusters so they can put the switchgear back in a good working fashion. So these are things that we'll help you to get help with through our other companies or whoever you're going to work with, but we can help you through the use of the RRS-1 to identify that you may have a problem with your switchgear. The next breaker we're going to work on is going to be the Powl-Vac. The Powl-Vac is a breaker we'll find in use all around the world. We'll find these things in the Middle East. We'll find them in all sorts of countries. So we've seen them in a great range of places. And one of the things that I'll point out before I put the machine up here is this. Normally you've got a label here which is going to say disconnect, test, and connect. And sometimes when you get a little bit of wear and tear in these racking mechanisms, you may have the system where you've racked it in physically all the way, but you're past the actual interlock for the operation. You may have to actually back it off and center the word connect in the window to get the breaker to properly function. Okay, so that's one of the things you need to note and understand about this family of switchgear. I had that happen the first year I was working for CBS ArcSafe at a power plant up in Missouri. We'd racked the circuit breaker in and out plenty of times, and when they, at the end of the day, they forgot to put the fuse blocks in, And so they put the suit on to do it, and they thought that the circuit breaker was broken. We hooked it up to a tester. They racked it in all the way, and when I noticed that the word connect was past the window, I simply used the manual tool to back it up to the window, and the breaker functioned properly. It wasn't broken, it just had wear and tear in it. And that's one of the things that you need to understand is you have to work to look at the condition of your switchgear. Remote racking doesn't fix your problems, it helps you identify the problems, it helps to keep your people safe. So when you're working with a breaker like this, as long as it operates normally, when you get to the end of the racking mechanism, that's great. But if you have to back it off a little bit, don't be surprised if you've got one in there that's been there for a long time, and that's what you have to do. So the first two breakers we used our foot latches on. This breaker, we've actually got a tetherless tool in here. We've got a magnetic tool because the unit's going to walk back and forth with the circuit breaker. We aren't going to put the foot latches on this time to rack the breaker in and out. So some of the things to note also is for our domestic customers, when you're dealing with breakers that go up to about 15 kV, the RRS-1 is only going to travel about 10, maybe 11 inches. When you get to some of the IEC breakers that are out there, we have seen, the most we've seen a circuit breaker move with a rotary type of racking mechanism is 21 inches, and with an extractor type mechanism about 47 inches. So we work to help you identify what it is, what it takes to do your particular type of switchgear. Okay, let me see.
Greg, we might also show the light here too for like
yeah.
Light environment.
Mm-hmm. Okay, so one of the things, if you're like, what I'll tell you is this: on rotary style breakers, about 15% of the time we have customers that need the lights and the camera. Okay, on extractor type breakers where we use an RS2, that number goes up to 99%. Well, if you've got a large arc flash hazard boundary where you can't stand in the substation, and I've been in a cement plant, I won't say what company, but down in Midlothian, Texas, so that gives you 3 companies there. Their VCP-W had a 294-foot arc flash hazard boundary on the switchgear. With the radio remote system, we can get out to 100 meters. So we sat out in the parking lot under the live oak tree and watched the RRS-1 rack the breaker in and out safely outside the arc flash hazard boundary. So if you have high arc flash hazard numbers and you need the radio remote and you need the video monitor, we have that capability. While we're not showing it to you today, understand that we can easily do that. And again, we call us at 1-877-472-3389 or info@cbsarcsafe.com. We do free on-site demonstrations and site evaluations as part of our sales process to help you through the process. So we've got this hooked up now, and I'm gonna, let's see, I'm just gonna increase the install to 10.2. And my remove is, I'm going to go back up to 8.2. And now we're just going to hit the remove button here. And out comes the Powl-Vac. Again, similar numbers for all the switchgear. There goes the shutters. And now we're going to go back in. The tetherless tool allows us to use a mag switch magnet on the system for it to be able to stay and walk back and forth without having to use anything else. It just goes right onto the front of the circuit breaker and allows us to overcome the rolling friction of the RS-1 and draw the breaker forward or move it, or draw the unit forward as the breaker moves in or comes back with the breaker as it pushes it out. Okay. Move that one out of the way. The next circuit breaker we're going to do is the Westinghouse the Westinghouse DHP. This is a 15 DHP breaker. The funny thing about the Westinghouse DHP racking mechanisms is it free spins at the end of the operation. So you're just going to hear a clunk, 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 clunk on it when it completes the racking operation. It doesn't reach a force limit when it gets to the end of the racking mechanism because it doesn't reach a screw limit, so to speak. Brakes off. Let me just turn my glasses on. Normally I would do this from the other side of the machine, but so that you can watch, I'm doing it from the back side of the machine right now. Okay. We will still set a force limit on the breaker in terms of how much force we're going to let it generate. Playing with these breakers in various facilities, I'm going to set the install value at 19 and the remove at 15. And that's a fairly good number for this type of circuit breaker. One of the things I will mention is I ran into one of these breakers up in Alaska. I won't say with which utility. They had one in a downtown substation that had not been racked in over 10 years. It took 27 amps and foot-pounds to get that breaker out. The racking mechanism had a little bit of corrosion on it because it was, again, in a marine type environment close to the ocean. They had another similar breaker, exact same size, that was in a hydroelectric facility, and that one was only 7 or 15 to come out versus the 27. So that was the difference in terms of the condition, the wear and the tear on the breaker, how much it had been racked. And once we lubed that breaker up in the downtown substation, those numbers started to fall down because, again, we're working to get rid of the old grease, the dried on stuff, the little bit of corrosion, cleaning things up. So that's where an RS-1 can help you look at the condition of the switchgear and determine that you need to do a little bit of maintenance. All right, so right now the circuit breaker's in, and we're simply going to remove it. It just popped off the bus right there. It takes about 50 seconds to rack this circuit breaker out. And that's where the unit's out right there. So it's out. One other little tidbit of information about the DHP breakers. Westinghouse licensed the breaker to be made by Mitsubishi in Japan, and we've seen those breakers in the Middle East also. Westinghouse also licensed the breaker to be made by a company called Magrini Galileo in Italy, and we've seen those breakers in the Middle East and in a couple other locations. You'll see variations that'll say Westinghouse of Mexico or South America. So It's still a DHP breaker, okay, even if it's made by one of those other companies. And it looks similar to this one. So that's one of the things. For racking it in, again, easy enough for the install. And that's it right there. Now, I'd like to thank everybody for subscribing today or watching our video. We'll ask you, we've got one more breaker left, the ITE/BBC/ABB HK series. So if you like what you're seeing today, please hit the like button and also subscribe to our channel. So let me now move this to the next breaker. This time I'll do it the easy way from the Okay, a couple things I want to talk about before I get the RRS-1 hooked up to this are the HK family. So the racking mechanism on a 5 HK and a 15 HK are similar in terms of the latch to feet right here and the fact that you use the same racking tool. If you get to an HK 1000, it's a bigger breaker and a different tool. If you get to an HK 38, then it's even bigger. Okay, so those are things to understand. Now, with these breakers, we learned a lot of stuff the first year we were doing things, and I want to share some of those things with you. When you operate the HK breaker, before I start racking this breaker at all, the first thing I'm going to do is we're going to make sure that the switchgear is open, and then I want to see manually that this latch falls back into place. If that latch doesn't fall back into place, that means that you need to get the lubricant cleaned up once we rack the breaker out. Okay, because if you got lubricant that is old and gone from being grease to glue to cement, then your latch and interlocks aren't going to operate properly. And you need to get that stuff removed, cleaned off, so that things work like they're supposed to. The next thing is, I want to see that this doesn't go in and out like a sliding trombone. So on the side of this latch rod here, you'll have two small 1/8 inch roll pins. And if you've been putting a lot of pressure on this thing, you're going to break that front roll pin and this thing will go in and out like a sliding trombone. I want to make sure that it's not going to do that either. Also, if you see that when you remove this, that if the breaker's out, that this is bowed out to the left, what that means is people have been holding this thing displaced and not rotating it about the central axis of rotation for the interlock, but they've just been pulling it. And when they pull it, then what it starts to do is it actually starts to put stress on those roll pins. And you'll see on the top of this, though I don't have an example for you other than a picture I could show you or share later on if somebody were to ask the question, it looks like a series of half-moon divots on the top where the mechanism here is actually cutting out part of this latch rod as the breaker racks. And so you'll see a bunch of little half-moon divots on this thing about every 1/4 inch because of the wear. And that's trying to tell you you're going to have to replace this latch rod and the roll pins for things to work properly. Okay? If you have extensions on these, then we need to know how far inside the cubicle the breaker sits with the extensions on them for the right length racking tool. This tool that we have right here is for the 5 HKs, and we actually make 3 different lengths based upon what you have for switchgear and how far in we have to go get to the racking mechanism. Now you're going to notice a couple things that are peculiar about this. We've got a ring on the top and a ring on the bottom. And the reason for that is because if you're going to operate the interlock manually, let's say I've got switchgear that's all the way down on the far right side. Well, I can't stand on the right side of the machine and be outside of the arc flash hazard boundary, so I have to be able to pull from the bottom if I'm going to use a manual defeat with the leash here. If I've got the interlock defeat control on my RRS-1, then I can simply use it to defeat the interlock, and I'll have it hooked up here to the top. So I have to be able to operate from either the right side or the left side, the way that this thing works. We're going to close the door after we put the tool on here, and then we'll secure the door, and then we're going to put on our tether system on the door so that we can operate the both the latch release and also watch this go in and go out. One of the funny parts about the way that this racking mechanism operates is this. When a man's down on his knees, he doesn't see this. But you'll watch the RRS-1 when it happens, and you'll see that this really does happen. So when I start racking this, the breaker will move in a little bit, and then the RRS-1 will move back a little bit after it's gone in just a little bit. Then it's going to go in a little bit more. And when I come out, it comes out, goes in, and comes out. And it does this with all the families. Now, we had a company the first year we were doing this that somebody had misplaced the tape inside of the cubicle. And it had the disconnect, test, to connect stickers all next to each other instead of in the proper positions. And a man thought that he had literally racked this breaker through the bus, which is a physical impossibility. This breaker racks with a cam lobe on the side of it. So the farthest that the RRS-1 can rack the breaker is the extremities of the cam lobe. It can only go to the eccentricities of the cam lobe. You have a screw moving this. I don't know if you guys, can you see what I've got my hand on in the camera, Brian? Okay, so my fingers right here are on the cam lobe, and the screw rotates this cam lobe. And that's how the breaker actually moves, is the screw rotates the cam lobe on the side of it with a slot in the cubicle. Okay, so if you've got questions about this, please go ahead and ask, and we'll work to answer them. Okay, so I've got the tool inserted onto the breaker, and now I'm going to screw the door shut. Okay, that's good. I can see that the unit's the latch is operating properly. I'm going to stand off on the right side today, so I'll hook this up over here. Now, one of the other interesting things about this type of breaker, it's one of the few breakers where we'll actually leave the motor brake off when we rack the circuit breaker, because we want the latch to naturally fall and relax so that when we go to the next part of the operation, it's not binding at all, even though the unit works to shut off as instantaneously as possible when it reaches the latch. That should be pretty close right there. Okay. So now I'm going to do two things. I'm going to hook the RRS-1 up to the tether magnet, and then I'm going to hook the strap over here up also. I just need a little bit of tension on it so that it brings it back at the end of the process here. There we go. Just a little bit of tension is all it takes. Now, let's see. Dealing with a vacuum breaker like this, my install should be about 14.5 or less, and my remove should be at about 12 or less.
So right now we're fully removed, correct?
We're in the remove position, that's correct. So the funny thing is, when I first started doing this, it's sort of interesting. To rack the breaker fully out, what a person would have to do is you've got to latch, release you're going to release the latch, rack to the test position, release the latch, rack to the disconnect position, release the latch, rack it to the out position, you pull it out then, and that releases the springs. Okay? One of the things to note is you do not want to leave the latch pulled out during the racking process once you've got it moving. You want to let that latch release and ride like it's supposed to. If you leave the latch in a position of tension, so to speak, holding the cable, what's going to happen is you're going to start putting wear and tear on it, where you're going to start getting those half-moon divots. And then you're going to get wear, and you're going to have the roll pins break, and you're going to have to replace that whole rod and the roll pins. So the thing that we learned early on with this was let the sucker ride. Once you've got it moving, release the latch, let it go and fall into position and stop. Okay? So normally I would be much farther away than this. For the purpose of our demonstration right now, I'm going to show that I'm going to release the latch, and then I'm going to hit the install button, and you'll see that it comes out just a little bit. And now we're in the test position. Now we're going to release it again. We're going to hit install a second time. And now I let the lanyard ride. It's just now the latch is falling and going where it needs to. Okay, now to bring the breaker back out, we'll hit our latch, we'll hit remove. Oh. I let it go too soon. And you can see from the side, I don't know if you can see it or not, but it goes in and it goes out that little bit. We'll release it again. And that's racking the HK breaker. If you like what you've seen today, please hit the like button and also subscribe to our channel. Ben's standing by right now to answer questions, so we'll open it up for questions. Again, you can contact us at 1-877-472-3389 or info@cbsarcsafe.com.
Give it another minute or two. Another 30 seconds, 45 seconds.
Again, 1-877-472-3389 or info@cbsarcsafe.com. Feel free to call us, contact us, and ask us questions. We have over 800 different solutions for remote racking and remote switching, and we literally develop something new every week for somebody around the world.